Hey guys, and welcome back. If you've just tuned in, we're about to cover our last question for analytical geometry on this show today. We're so grateful to be here, brought to you by Liberty. We love doing what we do. This last question is brought to us by Mighty. Let's see what they need help with because we need to jump right in.
Hi guys, my name is Maite. May you please help me with this? Yeah, once.
Okay, this question is going to take a lot of work and a lot of understanding. So if I run out of time, guys, I'm going to try my best to explain it to you. But I'm just going to read it and get right into it. It says, L with its coordinates and K with its coordinates are 2 points on the Cartesian plane. 1. Determine the equation of the locus of the point P, xy, so that PL is equal to the square root of 2/3 multiplied by PK. Okay, first of all, what you need to understand is that the locus basically just means the pathway that the point P will travel. Secondly, remember what I said earlier, if you have sides in ratio to each other, try and get them alone. This time I don't really want to get them alone because I'm going to try and manipulate the equation as is, but I don't like that square root there. So I'm going to get the square root out. So I'm just going to square everything and say that PL squared is equal to 2/3 PK squared. Once again, I put the Cartesian plane here so that we can try and visualize what we're dealing with. So L will sit at about -2, 1, so that's there. K is at 1 and 2, so that's about there, are 2 points on the Cartesian plane. So basically they're saying to us that we need to find the path that any point P will follow so that the distance between P and L and P and K is in that ratio. Okay, so there's not only one point P that follows that path. There's so many points there that could fulfill that ratio. That means that that P is going to follow a path in relation to those given points that gives that distance ratio. Okay, so what we need to do is find PL squared and PK squared and manipulate them so that we find an equation that defines that relationship. Okay, so firstly, PL squared by the distance formula is going to give us x at P minus x at L, which was given to us at -2 all squared, plus y at P minus y at L, which was 1 all squared, and we're not going to square root it because we squared PL. Okay, so that gives us, this is going to become x plus 4. So we get x squared plus 8x plus, I'm talking absolute nonsense, x plus 2. So that gives us 4x plus 4. And then on this side, we're going to have y squared minus 2y plus 1. Okay, so let's further simplify this. We get x squared plus 4x plus y squared minus 2y plus 5. Okay, so that's our one equation. Secondly, we're going to try and find pk squared. So that's going to give us x minus the x value at k, which is 1 all squared, plus y minus 2 all squared. Let's multiply these out so we get x squared minus 2x plus 1 plus y squared minus 4x plus 4. Okay, if we keep on simplifying this, we get x squared minus 2x plus y squared minus 4x plus 5. And that is our second equation. Okay, so remember from up top here, we said PL squared is equal to 2/3 PK squared. So now we can go and put that into that equation. So PL squared is over here, PK squared is over here. So we say that original thing, x squared plus 4x plus y squared minus 2y plus 5 is equal to 2/3 of x squared minus 2x plus y squared minus 4x plus 5. Okay, so now we can try and simplify this equation. I'm going to multiply out by this 3 so I get rid of that denominator. So that gives us 3x squared on this side plus 12x plus 3y squared minus 6y plus 15 is equal to, remember that this is multiplied by the whole thing. So Going to distribute 2 into the brackets. We get 2x squared minus 4x plus 2y squared minus 8x plus 10. Okay, so now we just need to simplify. 3x squared minus 2x squared gives us just x squared. 12x plus 4x, because we take it to the other side, is 16x. 3y squared minus 2y squared gives us just y squared. And lastly, 6y. This is meant to be a y on this side. Look at me writing out some nonsense. Okay, so negative 6y plus 8y gives us positive 2y, and 15 minus 10 is 5. And that is basically the pathway that point P is going to follow, guys, in order to establish that relationship. I know it looks real icky, but if you look at this, it kind of resembles some other stuff that we've been dealing with today. We've got x squareds and y squareds are equal to something. That should immediately ring a circle bell for you guys. Remember, if you have x plus something squared plus y plus something squared is equal to whatever, that's an equation of a circle. Okay, so that ties into the next question here. It says, what type of figure is described by the locus of P? Substantiate your answer. Okay, so I'm going to answer on this side because I want to have this equation handy. But we've got this big expression here for the locus of P. Okay, so if we complete this square, we get x plus 8 squared minus 64 plus y plus 1 squared minus 1 plus 5 is equal to 0. If we keep on simplifying to try and get to a circle, we're going to end up with this being 60 on this side. And that is the equation of our circle, guys. It means that we have a circle with the center negative 8, negative 1, and the radius of root 60, which is the same as 2 root 15. Okay, so when you get a question like this, guys, and you get this whole gross situation that's explaining a locus of something, it's basically asking you to try and identify that this is a circle. It can be manipulated to form a circle. So P will follow a circle around one of the points or around another center point to establish that ratio between the two lengths. Okay, so hopefully you've understood this question, guys. I really did try my best given the time that we've been given. That's it for our show today. Thank you so much for tuning in. Thanks once again to Liberty for sponsoring us. Send in your analytical geometry questions, guys. Also, we're going to start jumping into exam revision. So keep an eye out on our Facebook and our WhatsApp for posts about that. We're going to start revising for your June exams. It's going to be really great. We're going to compile some great content. Thank you for tuning in. We will see you tomorrow, same time, same place. Have a great evening.